I believe that this nation should permit itself.
Extraordinary television picture here.
50 years ago, two Americans set foot on another world for the first time in human history.
Hi, Roger. You're loud and clear.
It was July of 1969, and the whole world was watching
Step off the limb now.
as Neil Armstrong and Buzz Aldrin stepped out of the lunar module and ushered in a new age of exploration.
Okay, now I think I'll do the same.
Not only was the moon landing itself an extraordinary feat, and the science performed unparalleled in human history, but the samples our astronauts collected would change our understanding of Earth's nearest celestial neighbor for decades to come. On July 24th, after traveling over 950,000 miles in a little more than 8 days, the Apollo 11 crew began to re-enter our planet's atmosphere, beginning the final stage of their dangerous journey home. Their parachutes deployed, and our astronauts safely splashed down in the Pacific Ocean, where the USS Hornet aircraft carrier was awaiting our new heroes. With navigational precision, our U.S. Navy quickly lifted them up into a helicopter and delivered them safely to the deck of the USS Hornet, where the astronauts entered into quarantine as a new era of lunar science began. 50 years later, we come to you live from that same U.S. Navy aircraft carrier.
Welcome to NASA Science Live, where we're coming to you aboard the USS Hornet, a Navy aircraft carrier, now a museum here in Alameda, California. This ship has an unprecedented history. It helped lead the victory in the Pacific in World War II, and this is the ship that brought back to shore the actual Apollo 11 capsule crew and the first ever samples from another world here back to Earth. I'm your host, Dwayne Brown, and we are celebrating as a nation the 50th anniversary of the Apollo 11 lunar landing. You're going to hear a lot more, get the behind-the-scenes look as only NASA Science Live can bring you, and interact with our guests here on Facebook, Twitter, and send in those questions using hashtag AskNASA. And if you're watching online, use the comment box for your questions. Behind me is a crane, very unique, just like the USS Hornet. It actually hosted out of the ocean the Apollo 11 capsule. You're going to hear about that. You're going to hear about the ship. You're going to hear about the science from the lunar samples, the challenges of taking humans to the moon and getting them back. And we have a crew member, yes, a crew member, who was stationed aboard the USS Hornet at the time of the recovery operations. It is going to be magnificent. And you might want to look out for some items that you never knew about in Apollo 11. So welcome aboard. Let's learn more about this incredible ship, the USS Hornet, from a USS Hornet tour guide, Cindy Savoy. Over to you, Cindy.
Hi, good afternoon. My name is Cindy Savoy. I'm a docent here on the USS Hornet Sea, Air, and Space Museum, and welcome. We have the largest Apollo exhibit outside the Smithsonian in Washington, D.C., and President Nixon chose us to be the recovery ship for the Apollo 11 astronauts, the first men to walk on the moon, because we were decorated and we're famous. Historically, we are kept in our authenticity, so we remind you exactly what it was like in 1969. Here I'm standing in a replica of a living room, the way it looked in July of 1969, with a TV that we had to get up and turn the channel, and a shag carpet. We also have a picture of President Nixon, and he was very proud of us, and that's why he was the only president to come to the Hornet or to a carrier to represent the United States and welcome back astronauts when they came back from the moon. So I would like to point out some artifacts that we have here that we will go over later on in the program. We have the MQF, Mobile Quarantine Facility, where the astronauts were placed after they came back from the moon. We have a famous helicopter, number 66, and this helicopter was also in the movie Apollo 11 with Tom Hanks. And then over here we have the Apollo capsule and a Gemini capsule, and we will point those out later on in the program. So welcome to the USS Hornet Sea, Air, and Space Museum, and we will see you soon. And back to you, Dwayne.
Well, thanks, Cindy. And we'll be coming back to you a lot more to hear about these artifacts on this incredible ship, the USS Hornet. So this is the NASA Science Live set here on the Hornet, and I'm joined by NASA's top scientists, or officially known NASA Chief Scientist Jim Green. Welcome aboard the USS Hornet, sir.
Man, is this fantastic. Beautiful aircraft carrier.
It's amazing, isn't it?
It is.
the NASA chief scientist has a unique role. Explain.
Well, I'm the independent advisor to the administrator on science activities. So that allows me to review our programs, which I'm really excited about, but also tell him about some of the exciting new discoveries that we make almost every day.
Right. This looks like the moon, so let's get to the point, Jim.
All right.
Out of all the discoveries made during the Apollo program, what was one of the biggest?
All right, I'll tell you what one of my favorite one was. So here we have the Apollo 11 site right here. The landing site is in Mare Tranquillitatis. This is also called Tranquility Base, and as you can see, it's between these dark area that we call Mare and the lighter crust. Now, what they brought back was about 50 pounds of lunar material, beautiful sets of rocks and regolith and all sorts of things like that. And one of them was a real find. It was an anorthosite. Now, yes?
What? Sounds like a rock band.
Yeah,
okay.
yeah,
I think you need to explain that one.
Anorthosite. This is a particular rock that loves to float on top of lava. This was very important because it helped us distinguish various theories on how the moon was created. A couple of the theories are, well, we captured it. Another one of the theories is the Earth was spinning so fast it just lobbed off a chunk. But the one that we really wanted to look at was what's called the giant impact hypothesis. So let me take you back 4.6 billion years. The Earth was being created, a proto-Earth, if you will, but another object in the area called Theia, about Mars size. The two attracted. Theia hammered the Earth, but was blown apart. What happens next is the remaining material of Theia comes together. So if you can imagine molten rock all over the place coming together to form a new object. On the surface, it's a complete molten rock area. We call that the lunar magma ocean. And what floats on that is the anorthosite. So by that one piece of anorthosite that we brought back from Apollo 11, it really helped distinguish the theories. The giant impact hypothesis is the one, even today, we believe, created the moon.
So does that mean the moon is Earth's little brother, or?
Yes. In fact, the more we look at material from the moon, the more we see it's so much Earth-like.
Fantastic. Okay, so we're talking Apollo 11. We're
Yes.
going to talk that, and then we're going to go into the future. There's an interesting story about the rocks when they came aboard the aircraft carrier. They dealt with some little crawly things.
Well, I tell you, we did not know much about our nearest neighbor, all right? And so we have to be very careful. Bringing material back from space may have pathogens, those things that would affect our life, and so we had to be very careful about that. So we then had a series of processes to determine that the astronauts, when they came back, were safe to reintroduce into our population and didn't have pathogens with them that they brought back from the moon. So the first thing, if you can imagine, there's the capsule floating in the water, and the scuba divers come up. They throw into, if they open the hatch a little bit, throw into the capsule 3 suits, and these are called the biological isolation garments.
Big for short, right?
The BIGs, that's right.
Always an acronym.
Always an acronym,
Always,
right.
Okay.
So they put these BIGs on, okay. Now that was supposed to then keep them isolated, okay, from what was going to happen next. So they then took them out of the capsule, brought them up. There's 66 right there, 66, that beautiful helicopter, one at a time, and then brought them back to the carrier, brought the little Hornet, landed on the deck. From there, they then moved into the mobile quarantine facility, which is an Airstream trailer, and then locked it up, all right? So now they're really isolated. What happens next is we then have access to the lunar rocks, and in a controlled environment, we add mice, okay?
Mice?
Yes, we added mice, and we wanted to see if there were pathogens in those rocks, okay, and whether the mice would survive or not, and of course they did, and that enabled us to realize that there's no pathogens for us to worry about on the moon.
Sort of like a canary in a coal mine.
Yes, exactly. That's a perfect analogy, and so once that happened and the canary kept chirping, we opened the door and let them out.
What do we do with the mice?
I don't know what happened to the mice,
Okay.
but
they served their purpose.
they served their purpose.
Fantastic. Okay. Welcome again to NASA Science Live, where we're from the USS Hornet. Send in your questions to #AskNASA, and we have some. We're going to take some, Jim.
Sounds good.
First up from Pierre on Twitter asks, is the moon considered another world?
Very good question. You know, the moon is a significant body in size, all right? It in many ways is almost planetary scale. And in fact, if it orbited the sun, we'd call it a planet. Mm-hmm. You know, that's how that goes. So yes, I would say the moon is really not only another world, but planet size.
Another question from Barack on Twitter asks, what did the astronauts see on the moon?
Well, Buzz described it, I think, very well. They're in the beautiful pictures that we brought back, and he called it magnificent desolence. You know, it was eerie. It was, you know, had gray tones. It just was another world. And contrast that with when they saw the Earth. You know, the beautiful blue, you know, marble, as we call it, with oceans and clouds above them. It was quite the contrast.
Another question on Twitter from BK Hennig asks, what was special on the rocks we got from the moon?
Well, actually, we really have been teasing them out. We don't analyze all the rocks. From all 6 Apollos, we brought back about 840 pounds of rock material. 25% of that we've kept aside. All right, we haven't interrogated them, and that is because we want to look at the rocks that we have. We want to be able to analyze them, learn new things so that we then can use the additional samples. Plus, the laboratory equipment is getting so good. We can take CT scans. We can look inside. We can see what are called isotopes. We can figure out the mineralogy and how these atoms are aligned in matrices to make up different rock material. And what we find is that the moon is mostly Earth-like.
Wow, mostly Earth-like. Okay, keep sending in your questions here at #AskNASA. We're now going to go back to Cindy, where she is next to the test capsule that was used by the USS Hornet and the mission team to make sure that they were ready for the recovery operations for the real thing. Over to you, Cindy.
Hi, welcome back. I want to introduce you to our Apollo capsule. If you look inside, you can see how tight it was for 3 men to be in there for approximately 7 days. Now, it's very tight. They had on spacesuits. They were limited mobility in there, except Michael Collins was very lucky because he was orbiting the moon for 22 hours while Neil Armstrong and Buzz Aldrin were on the lunar surface. So he had room to spread out and relax, and he didn't have to talk to anybody. He absolutely loved it. If you look inside, there are some spaces that are vacant, but down there, you would probably have a lot of equipment and supplies throughout the whole unit. But this capsule actually was very important. It's the exact replica of the one that went to the moon, but this went to space to test the heat shield and also the instruments inside, but it was unmanned. Once it came back from the Earth, it wanted to see if it would actually tolerate a hard landing. We actually launch from over the ocean and we land in the ocean for soft landings, and we'll show you why. Let's walk around and look and see why a hard landing has severe implications. If you look at this, they dropped it from a high tower and it landed on a hard surface, and this was the impact that happened. You come around to the rear, you come around all the way to the rear of the capsule, and look at this, it actually cracked the structure. And you see the cracks and holes in it. So this would not have really survived hard landings, and they actually donated it to us, so it's on loan for us to enjoy, and so that our public can see it, and it's good for education purposes. You can see the heat shield has been replaced, but this is demonstrate the concavity, how the heat shield is built. Actually, all the wiring that is throughout the capsules for electricity, for communication, and for scientific research, to gather scientific research. So if you look, we're going to come back here to the front. And hi, Dwayne. How are you?
How are you, Cindy?
I'm fine. How are you?
We're keeping you busy today.
Yes.
An honor to be here, and thank you so much.
You're welcome.
Okay, so you talked to thousands, millions of folks about this incredible facility and the history. What is one of the more common questions you get about the capsule?
Well, actually, because there was 3 men in there for 7 days, a lot of the kids want to know what was the environment like when they came back from the moon, the smell. So I asked them, I said, now you've been in there for 7 days. You left, you came back what you left with. Did you take a shower for 7 days? And the kids go, oh, no. They said, yeah. It's very, very memorable.
I can only imagine, but we won't go on graphic details on that.
Yeah.
One more question. Obviously, when we're talking about space travel,
Yes.
there's a lot of math involved.
Yes.
Now, they didn't have computers back then in doing Apollo.
Right.
It reminds me of the movie Hidden Figures, right?
Yes. Yes.
A little more detail on that.
Well, what they did was they used slide rule for calculations. They used the sextant for navigational fixes. For celestial fixes, they used the sextant, and also they had the communication system was not as sophisticated, so they practiced a lot in communicating with Houston and back and forth, and a lot of it had to do with how they were going to tolerate landing in the ocean. So when they did land in the capsule in the ocean, they were basically upside down, and the ocean was moving quite a bit. So when the astronauts came out and they had on their big suits, they had to be very mobile, and they had to be quickly transferred from the capsule to the Hornet.
These are the biological isolation garments.
Yes, the big suits, right. And so they had to be transferred and quickly removed from the capsule into the helicopter to the Hornet, and then they went into the mobile quarantine facility, which we will talk about at another time.
I'm looking forward to it, and we'll see you later in the show.
Yes, thank you, Dwayne.
Absolutely. Now we're going to talk about technology, because technology is very important, and we're talking about a technology that if it doesn't work, we're going to have a bad day. I'm now joined by Jeremy Vander Kam.
Yes, sir.
Love the name. It's very cool. What's your title and what do you do?
So I'm the Deputy Manager for the Orion Thermal Protection System, or TPS. And that material is what goes around the outside of the vehicle to protect it from the heating during reentry.
Okay. So, the heat shield, very important. Why do we need the heat shield? But better yet, how do you design it to make sure it works?
Right. So we have two major types of heat shields that we create depending on the mission being flown. And really the most important factor there is how fast you're going when you get to your destination. The first type of heat shield material we use is an insulator. This is a tile material that's been used on the space shuttle and that we use some on Orion. It's made of silica fibers. And for these materials, they'll look about the way they did when they launched, when they come back, where their surfaces can reach temperatures between 2,000 and 3,000 degrees Fahrenheit, but the part that's attached to the vehicle will stay a nice, comfortable 100 degrees Fahrenheit or so. For more aggressive missions, like what the Apollo missions were doing, and like what we're doing on the Orion capsule as part of the Artemis program, we're coming back from the moon, now we're going like 11 kilometers per second. We have to use material systems that are ablative. This is one of the, this sample here was actually taken from the first Orion flight test in 2014. The way these work is that their surface temperatures may be between 4,000 and 5,000 degrees Fahrenheit. That energy actually reacts with the material and consumes the material, and that consumes energy itself. So we can tolerate much higher temperatures and keep the part that's bonded to the vehicle, again, a nice, comfortable, say, 100 degrees Fahrenheit.
Fantastic. So, okay, so you mentioned Orion, and we're going to talk about the Artemis program a little later in the show. Now, what is the difference between the Apollo material in the process versus Orion?
So there's some very, very close similarities. So the Apollo capsules used a material called AvCoat over their entire surface. And that's actually what this material here is. So for Orion, we use AvCoat on the base heat shield. And for our first flight test, we actually built it the same way that Apollo did. And it looked very much like this. It had a honeycomb structure, and it had our ablative material inserted into each cell of that honeycomb. Now, as we move forward into the Artemis program, we're using that same material, AvCoat, but we're building it in a different way, where there is no honeycomb structure. Instead, we're molding it into blocks that we can bond on, and that gives us a much more efficient manufacturing process. Also on Orion, we're using insulative materials on the cooler parts of the vehicle, again in tiles, that allow us to have a very efficient manufacturing process compared to what Apollo did.
Wow, that's fantastic. And this looks sort of like my coffee table at home, but I'm quite sure it's a lot more.
It might be a little
advanced.
more expensive.
Yeah, and probably you probably can't afford that. So we're going to go to hashtag Ask NASA, and we've got lots of questions coming in, and keep those questions coming in. So we have a question from Keith on Facebook. What was the material used for the outside of the Apollo capsule?
So that was the Avcoat material that we just
okay.
discussed. Yes.
Okay. And we have from Mark Wayne on Twitter asked, will this technology be used for everyday life here on Earth?
Our heat shield materials typically don't find their way into everyday life on Earth. They're created to do exactly one thing, and that's to be a heat shield material. So you won't see them around except in museums on spacecraft.
So working on a team that's so important, give us some sort of idea of how big a team would be for the Orion that we're talking about that. And is there anything that may keep the team up at night as we get close to launching?
Yeah, so we're between 40 and 50 people between our industry partners and the various NASA centers. We sleep pretty well at night. Our biggest challenge is that when we test these materials on the ground, we use a facility called an ArcJet down at NASA Ames Research Center. And in those facilities, we can only test samples that are between 4 and 8 inches in diameter, which is a lot smaller than a full-size spacecraft. So until we get our first big flight test doing the actual mission at full scale, which for us will be the Artemis 1 mission, there's that little bit of uncertainty left that we haven't quite gotten out of the way yet.
Okay, let me take another question from Kimberly on Twitter. Asks, what type of educational background do you need if you want to be a part of the future Artemis program and work on heat shield technology?
Well, across the program, anything in the STEM realm will work. For our heat shield team, we have a lot of material scientists, we have a lot of mechanical engineers, a lot of aerospace engineers, systems engineers as well.
How did you get involved in this? I mean, were you tinkering with things as a kid or building things? Or?
I don't know. I had an obsession with anything that flew since I think I was born, and yeah, just found my way into NASA and found my way into the Orion program when it started in 2006, actually.
Wow! And so when we look back at the Apollo, and this is the test capsule, did you like study manuals or talk to folks as you to build on Orion?
Yes, that was a big part of starting Orion. We went back into all of the history we could find. We were pulling file cabinets out of garages full of files and papers and reading everything we could get our hands on. We studied all the old vehicles in their museums to learn as much as we could about what they did and what we could bring forward.
So what's the next step now? And again, we're going to talk about the Artemis program later in the show, but Orion, explain Orion and the capsule and what's taking place now.
So right now we have flown one flight test in 2014. The Orion capsule that will fly the Artemis 1 mission is complete just last week, I believe. And that mission will launch in 2020, 2021. And we're actually already starting to build the Orion capsule that will be on the Artemis 2 mission further on, the first mission with crew on board.
This is really cool. So Jeremy, thank you a lot again. So now we're going to go back to Cindy. And again, you're watching NASA Science Live aboard the USS Hornet. Send in your questions to hashtag Ask NASA. Cindy is now next to the helicopter, and the helicopter has a unique story. In fact, this helicopter was in the movie Apollo 13. Cindy.
Hi, welcome back. And we're in front of our Apollo number 66 helicopter, which was in Apollo 13 with Tom Hanks. The original one no longer exists, and our aircraft restoration crew saw this in Tucson's boneyard and said, is that 148999 what actually did fly off of the Hornet during the 1960s? They brought it back here to the Hornet and restored it to the mint condition that it's in right now. So let's take a look at it. This helicopter is so important because it's built in such a way that you wanted to have a lot of room in there, because when the astronauts were actually picked up out of the flotation device, they had to come in here and they were told, all the crew was told, do not touch them, don't go near them, because they could have some contaminants on them, even though they had already put the anti-contamination fluid or solution on their big suits, bioinsulation garments. It was about 40 feet from pickup from the flotation device into the Hornet, into the basket to bring back to the Hornet. Once they were able to come back, they were on the flight deck. The whole unit, descended here to the Apollo surface, and then they went in with their masks. They had special respirator mask on, and they were transferred immediately into the MQF, where we will talk about at a later time. This unit actually is so famous because it's so built in such a way there's so much room that the exact model is also used for Marine One, which the President of the United States uses. Also, you can look at the way the landing gear is. If for some reason it has to land on a soft surface, which is the ocean, the landing gear retracts and you have some floating devices in here. This is a very unique one. We're very proud of our air restoration crew for what they did to bring it here so you could enjoy it. And it's historic because of the movie and just the way that it operates with the jet engine up there on top and the big rotors for maneuverability. So welcome back, and hopefully we'll see you again soon.
Thanks, Cindy.
Back to you, Dwayne.
Thanks, Cindy. We're back here on the set at NASA Science Live, and I'm joined by another scientist, Kimberly Anico. Welcome.
Thanks, Dwayne.
You do a lot. Tell us, you're involved with a whole bunch of cool things.
Well, I'm a research scientist at NASA Ames Research Center in California, Silicon Valley. Our center does innovative approaches to open questions in aeronautics and basic fundamental space research, and have been working there for a number of years, and I work on lots of different mission concepts. I'm trained as an astrophysicist, so I've built instruments that have flown in space and in the air. I actually had built a payload that crashed into the moon and found water on the moon, and I have been doing science management through the New Horizons Pluto flyby, and most recently on our flying telescope, SOFIA. So as a scientist at NASA, I'm interested and attracted to these questions that drive us to push ourselves to new limits and opening up creative solutions, and it's a fun job.
Wow, that's a pretty cool shopping list, and you even come dressed for the part. You know, you got the moon. I mean, that is awesome.
Well, Dwayne, where's your Mars tie?
Oh, I forgot. I'm sorry.
This is inspired. It's a conversation starter in a sense. I mean, the whole opportunity to speak about space and science and exploration and discovery and making the impossible possible is inspired by Apollo 8, where Bill Anders took the first picture of the Earth from lunar orbit. So our first humans who looked back on our home world for the first time.
Wow. Okay, let's talk science during Apollo. And you have some interesting things here. This looks like Earth, but I'm pretty sure it's not, right?
Yes. So earlier in the show, you and Jim were showing a grayish globe, which was the moon. This is still the moon, but it's actually a map of the height of the moon. And this is post-Apollo, and this is when we had a series of robotic explorers doing orbits around the moon. One in particular, the Lunar Reconnaissance Orbiter, and one of their instruments measured topography, how high something is. Blue represents low areas, so what was known as the mare are low areas, and red on this globe shows high areas. And I'll turn it around to show the far side that we don't see. And the far side is exotic. Did you know that the average height on the far side is over a mile higher than on the near side? And it has the most extreme topography because the highest point on the moon is higher than the highest point on Earth, Mount Everest. Also intriguing, on the far side down to the South Pole is one of the lowest areas, a giant impact basin called the South Pole Aitken Basin. And this is an exciting area that lunar scientists are salivating to have an opportunity to have access to this part of the moon that we haven't had before.
Wow. Now, this little guy is really interesting, and I'm willing to bet it doesn't look like it came from the beach or a little hill, right?
You're right, Dwayne, and you're looking at an Apollo moon rock. This is from Apollo 15. But the lunar rocks that came back from the 6 landed missions have transformed our understanding of how the moon formed, and also indications of what happened early on in our solar system. In addition to over the 6 landed mission, 840 pounds of rock, about 2,000 different samples, the Apollo astronauts put instruments on the surface of the moon. Apollo 11, they only had 2.5 hours on the surface. When we got to Apollo 17, we had about 3 days on the surface. Each different Apollo mission did more science. Buzz Aldrin, during Apollo 11, put out a seismometer. This would measure quakes, moonquakes on the moon. We also put these retroreflectors. Retroreflectors allowed us to measure the distance between the Earth and the moon, and also learn about measuring its orbital rotation and the spin of the Earth's rotational axis. We had a dust detector on Apollo 11, and also an interesting instrument to measure the particles coming off the sun, because the surface of the moon is a wonderful laboratory to do science from.
So all of those science experiments, and how many were there again on them?
Well, on Apollo 11 we had about 4, plus the photographs, the motion pictures, and the fact that the Armstrong and Armstrong's footprint is an experiment in itself. It showed about the properties of the lunar soil regolith and how it impacted upon pressure. And so you might hear Aldrin talk about, I only went about ½ an inch or something like that. That was telling the scientists, because up to then we had no idea what the surface of the moon would touch and feel like. So even them walking on the moon themselves provided information about the lunar surface.
Now I asked Jim there were so many findings, but what he thought was the biggest. What would be next in line?
Next in line? Well, it's when you look at the moon, you see all these craters. But we didn't really know what the dominant mechanism is to make the surface of the moon. And the Apollo astronauts and the landed mission showed us it was impacts, things hitting the moon, rather than plate tectonics like we have here on Earth, or active volcanism that's reshaping our surface. So by that, and by the continuation, the moon has preserved an early history of our solar system that is forever lost on our planet. So we want to learn about the early Earth, we look to the moon. We want to learn about the early sun, we look to the moon. And those mysteries are still being teased out, and it's all done by the surface measurements on the moon and the samples we return from the moon.
Fantastic. Well, we're going to go to social media and #AskNASA. Keep those questions coming in if you're just joining us. This is NASA Science Live aboard the USS Hornet. We're talking Apollo in the past, and we're going to talk about future lunar exploration and beyond. Our first question is from Enrique, who asks, how much water is actually on the moon and why?
Oh, great question. In fact, we couldn't even have this conversation 10 years ago, because the concept of water on the moon is a relatively new discovery. And this is the beauty of science. We haven't figured everything out. About 10 years ago, several instruments, including a mission that I worked on, we discovered water on the moon. And then since then, we have water found in different arrangements on the moon, and in particular, the poles. The poles have special areas where the bottoms of craters have not seen light, and so they're very cold, colder than the surface of Pluto. And they have become cold traps where water is migrated. How much is there? Well, from the knowledge we have to date, it could be 100 to 200 million tons of water, but we still lack the detailed maps to know exactly how much we have. Right now, our knowledge of the moon is almost like we have the knowledge when you're planning a hike. You have a knowledge to drive your car to the trailhead. But if we need to go to walk to that waterfall or walk to that cliff, we need more detailed maps, especially about the water. Water is scientifically interesting, and it's also important for a sustainable human presence on the moon, because water can be oxygen we breathe, hydrogen and oxygen for fuel. It's a wonderful resource and an interesting scientific discovery that is only 10 years young.
Wow. Stephen asks, what happened to the instruments on the moon? Are they still on the surface?
Yes, they are. In fact, some of the instruments are still in use. Can you imagine 50 years later? Those retroreflectors I mentioned, these are glass mirrors or prisms that you can beam a laser beam from Earth, and it bounces right back to you. So if you measure the time it takes and you know the speed of light, you know the distance between the Earth and the moon. And over 50 years of measurements, we have measured that the moon is receding from us about 1.5 inches a year. Most of the instruments on the surface of the moon, they had to survive a 340-hour lunar night. It got really cold, and some of them didn't make it through. We had other instruments that lasted several months and weeks through the mid-70s. But to go back and put new instruments on is very exciting.
We're running out of time here, but I've got to get this question in because I think this is so important, from Mary on Twitter, who asked, what got you involved in science?
Well, it's hard to say. I mean, I was a very curious child, I loved learning, and I'm really grateful for the education and the teachers who tolerated my many questions I had. But I was also empowered to realize that, you know, asking, we have this short time on this planet and we're learning so much. I just became very curious, and the science career just fell into that because I just had a very open mind.
Yeah, your passion is infectious. So we're going to talk some more
Okay.
and get into the future later in the show.
Future.
Now, what if I told you you could actually hear data? Now, work with me here. A group of musicians, and I appreciate this being a musician myself, have taken a tool and taken a song and put in the song 50 years of lunar science. It's called sonification. Let's hear more from moon data visualizer, Ernie Wright.
The pitch of the melody is telling you the amount of data that was returned about the moon over time. There's a clock sound that tells you about the progress of the months. And there are symbols that go off to mark the times of launches. During the Apollo era, the pitch rises as we learn more and more about the moon and gather more data. And then there's this period in the middle where it kind of falls, when we weren't sending people and we weren't sending robotic missions. It falls off a little bit. Starts to rise again to a crescendo in the modern era. In the sonification, there are these two peaks in the valley, but the other thing to take from it is that there is a continuous note of exploration. You know, the sound doesn't really go away. The past and the present and the future are all connected. You get that sense when you're listening to it that while there are variations in our level of interest and in the amount of data that we're gathering at any particular time, there's also a continuity that once we went there, we didn't want to stop.
Now, sonification is available at NASA on the new podcast, on the new NASA Explorer series. You can also hear it on Google Cloud, SoundCloud, Google Play, I should say, SoundCloud, and Apple Podcasts. And this cool technology was developed in Toronto, Canada by a company called System Sound. Now on the set here is someone, and I'm very honored that he's here on the NASA Science Live set, Skip Howard Robertson, a crew member on the USS Hornet. Sir, welcome. It's an honor. Thank you for your service.
It was my pleasure and my honor.
Let's go back in time. Today, 50 years to today, would be the day before tomorrow, which is the actual anniversary that you guys picked up the spacecraft. So the day before, what's the atmosphere on board the USS Hornet?
It's an atmosphere of expectation, excitement, wondering what was going to happen, how is it all going to work out. Would I get to see the president? Would he shake my hand? Which of course didn't happen. But we were ready for this thing to happen. We had been practicing extensively for weeks because it just doesn't happen overnight. So we had a dummy command module, which they'd drop in the ocean, and then they'd wake us up at 2 in the morning and say, go find it. Things of that nature. So we were ready, fully prepared. A lot of us were amused at the apprehension about moon bugs. But
Well, let me ask now, what was your role on the ship?
I worked in the radar area. I was a radarman third class. My job on the NASA recovery was the primary radio operator. So essentially, they would give me a piece of paper and I would read it. And so I had the distinct privilege of being the person heard around the world, although nobody knows that, saying, Houston, Hawaii, this is Hornet, we have Apollo on board.
How does that make you feel that you're etched in history? Because usually on a ship, when you make announcements, it stays within the ship. Did you know it was going to be heard around the world at the time, or did they tell you later?
They told me later that had been broadcast around the world. And out of the 1 billion or so people who were listening, only one person actually said she recognized my voice.
Did the crew members tease you, or did you get like a plaque or a cake? Or?
No, there was no recognition of that sort. We were all just part of the team. There were about 40 or so enlisted men, and I think 30 officers, something in that area, who were directly involved in some way. We all had a job. We did our job.
I have to tell you, we at NASA, we're humbled to be here, but we're in awe of all of the history here. Well, how do you feel when you come back to this magnificent ship?
Well, this is actually my first time back since I got out of the Navy in 1970. I was here 2 days ago and again today, and we'll be here tomorrow for the actual recovery day, you know, whatever happens then. And I have my cruise book, which we were given, all the members of the crew and many members of the civilian crew that were on board. We're given one of these, so I've got a lot of good memories in there.
Now, give us a short explanation. What's in this book? Are there signatures or pictures of?
It's pictures of what went on, shipboard life, the recovery. There's a picture, for instance, of Chaplain Pierto, who was the President Nixon for the rehearsals. Dandy guy from Wisconsin, which is where I live now, and just a lot of pictures of just routine shipboard life. Also pictures of crossing the equator. There were about 1,400 of us who are shellbacks, and there were about 300 or 400, including most of the civilians, who were pollywogs. And there are some pictures in here of that probably most of their families don't want to see.
Well, we won't go there, but Skip, I just want to say again, it's an honor, and thank you for your service. It's truly humbling to know what part you played in this historic event and the anniversary, and thank you again.
Well,
I know the grandkids and the kids are very proud of you.
Yes, they are indeed. Thank you very much.
Okay, we're going to go back to Cindy, who's in a very important area where the astronauts were whisked into as they arrived on the U.S. Hornet, the quarantine facility. Cindy?
Thank you, Dwayne. Welcome back. Here are the first footprints of Buzz Aldrin and Neil Armstrong as they exited the helicopter to go into the MQF, the mobile quarantine facility. Michael Collins' footprints aren't here because he did not step foot on the lunar surface. So when we go inside, this is a special airstream that was made for NASA. And it doesn't have a wheelbase, so it's just made just for NASA, for the astronauts when they return back from the moon. If you look inside, we have 6 seats. We have a technician and a physician who is in here with the 3 astronauts. So let's go inside. Very interesting inside because they had to be able to eat. They needed to use the facilities because remember, the 7 days there was no shower. So we had to go inside and basically have equipment for them to change and use the facilities. Now, Michael Collins wasn't feeling that well when he came back. So what he did was he was the first one to use the facilities back here. And you can take a look inside. It's very tight, but it worked. And what happened was, think about it. For 7 days, they were in that small capsule, not much room to move around. They said, why did you put them into another small unit? But look, this is luxurious compared to the capsule. And they have 6 beds for them. They have, oh, look what we have here. We have a microwave. This was made specially just for the MQF because they had to cook their food and they couldn't have an open flame to cook their food, and they couldn't have electrical coil because of could have been electrical fire. So what they did was they have a special unit just for the MQF to warm up their food and cook their food. Also, if you notice over here, we actually have an autograph by Edgar Mitchell from the Apollo 14 landing. And what he did was he actually, when they got to Apollo 14, they didn't need as much quarantine time as they did for Apollo 11, because the moon germs they found were not that significant to harm us as inhabitants of the Earth. They have regular food that they ate, and they also enjoyed the newspapers. What happened was when they were reading the newspapers, they had no idea they were that popular. And it said, United States, go to the moon, come back from the moon, the astronauts are heroes. Wow, really? We didn't know we were that popular. And when they got to Hawaii in the MQF, there was a big parade outside, and people were cheering and clapping and yay, and they looked out the window and they said, what is going on out here? Why all these people on the pier? And they got a hold of a newspaper that said that they were heroes. And Buzz Aldrin said to Neil Armstrong and Michael Collins, look, we were gone a couple of days and we missed the whole thing. They had no idea they were that popular. But they stayed in here for 52 hours. And the 52 hours, they went from the middle of the Pacific, they went to Hawaii, and from Hawaii they stayed in here, and they also went to Texas. When they went to Texas, they were quarantined in there for 15 days. Total quarantine was 21 days. Also, as you notice, they had to get the equipment from the capsule. So there was a plastic tunnel that went from the capsule to the MQF, where they could carry back the specimens and also bring any equipment they had to the MQF. Once they did that, the door was closed and everybody was quarantined, including their specimens in here. So welcome to the Hornet, and see you again soon. Bye.
Thanks, Cindy. And we're back. Thank you. I tell you, Cindy, you're doing great. And I just love hearing you talk. And I think I just come in too quick or whatever, but you are just absolutely fantastic. So we're back here on set, and I've got not one but two of the scientists that were already here, but now we're together. And you know what? You never know what to expect on live television. Somebody's birthday is today. Kimberly's birthday. Happy birthday. Oh my goodness, that is so cool. Okay, we've been talking about the past. Now we're going to go into the future. The Artemis program. Before we get into that, Jim, we talked about the rocks. What are the rocks? Aren't there some new samples that haven't been opened yet?
Yeah, indeed. You know, I mentioned that we kept some aside, and now we're ready to open them. And we have one very special type of container. It's a long, hollow cylinder that was used by Apollo 17. Jack Schmitt jammed it into the soils, actually in an area that we know was a landslide. So there's trapped gases and all sorts of stuff that we believe are there. And now that whole tube, which is full of lunar material, is going to be opened this year. In fact, we have to develop the right capability to capture all these gases.
And I want to thank, the scientists of the previous generation who had the forethought of keeping certain of these samples aside, pristine, untouched. Because as advances in our laboratory techniques, we can now extract a different type of science from that, knowledge from that. So, yes.
Well, that's fine. So, Kimberly and Jim, let's go into the future. We kind of mentioned the Artemis program, but Kimberly, let's go in a little bit more detail. What is Artemis, and what's going to happen with this program?
Okay. For those who know their Greek mythology, Artemis is the twin sister of Apollo. So we've been talking about the Apollo program, which was the humans on the moon. But the Apollo program had a different charge. The Apollo program was to put a human on the moon and return him safely to Earth. We scientists had other science that went along with that. Artemis is different. Artemis is a forward to the moon with a sustainable human and robotic presence on the moon and beyond, using the moon as a proving ground for Mars and beyond the solar system. Artemis is the first woman and next person on the moon in 2024. A giant leap for womankind and a humongous leap for humanity. It is also going to be the sustainable human presence using the moon with commercial partners, with international partners. Space exploration is no longer in the realm of superpowers and governments. We're doing this together. And that's what is, you know, to me, amazing. And so we're the Artemis generation. All of us are the Artemis generation.
Right.
We're on the backbones of the shoulders of the Apollo generation who brought us amazing engineering, transformative science, and a new worldview of what humanity can do to make the impossible possible.
And you know, we're here, and we're seeing folks all around us. This is cool. You know, this is a museum, so we got kids and everything, and they're excited, and that's what the space program does. But let me go back, because I wanted to ask you this before we got into Artemis. I was 9 years old, and I remember running around the living room, and my grandmother was watching something on the moon. But I was playing with bugs and things like that. I think you were in the stars at the time.
My parents were just dating.
Okay.
We hadn't been married yet.
So, Jim.
Yes, well.
What is your memory? Where were you? Apollo 11 landing.
I had graduated from high school, all right? So that summer was getting ready for going to the University of Iowa, and I had a fantastic opportunity on that Sunday afternoon to see the landing, you know, on my black and white TV at home. And, of course, later on, when they got out of the capsule and walked on the moon, it was just riveting. I mean, it was really quite a special time. Fortunately, I had already been so excited about astronomy and science. I knew I was going to get my degree in astronomy when I went to the University of Iowa. I didn't know at the time they were working on spacecraft. So I just naturally fell into the robotic spacecraft end of things.
So Kimberly gave a really great overview of Artemis and going back to the moon, not just to plant a flag, but be sustainable.
Yeah.
The first woman and next man.
Correct.
But Mars plays into this program a little bit too, right?
Well, indeed. You know, what we're going to learn to do is to live and work on a planetary surface. And the moon is the perfect one to do. It allows us to develop a variety of capability that we will use as we then go to Mars. For instance, getting access to the water, being able to break apart the water in the South Polar region where we're going to land, allows us not only to drink it, you know, H2O, water is water, whether it's on the moon or on the Earth. You know?
Or on Mars.
Or on Mars.
And we know there's water on Mars and it's subsurface, and on the moon we know it's a little surface and subsurface. So the techniques to excavate it, 3-day journey away. Mars, 6-8 months journey. Mars, different mindset, independent space exploration. Moon proving ground, we'll be ready for Mars.
Wow, you guys are right. Let's go to social media here. Hashtag Ask NASA. And we're going to take a question from Jimmy. Oh, this is perfect. Water. With all this water, does that mean life could be on the moon and Mars together?
Well, we don't think so on the moon. You know, we know that a significant amount of the water is probably due to cometary impacts from asteroids, which we now have a significant amount of water. And so that forms a cold trap in these South Pole and North Pole regions, and that water then ends up in the permanently shadowed areas. Since we've been to comets and we've been to asteroids, we do know a lot about them, and we don't believe that they have the ability to be biologically active. So therefore, we believe this is probably also true with the water on the moon. It doesn't have the kind of evolutionary environment, a habitable environment like an atmosphere and flowing water, but we have that ice there.
And a little known fact, did you realize there was a second lunar processing lab during Apollo that was at NASA Ames? And it was called a Lunar Biological Laboratory. Now, you know, to find life on the moon was considered highly improbable, but a good scientist will do an experiment. We did an experiment with 300 different environments to look for microbes on the lunar samples, because biology can exist in very different extreme environments. None was found. But the techniques and the instruments and the approach led to the development of an instrument for Viking that went to Mars in 1976 looking for life. And we're still trying to answer that question, are we alone? So design and development of looking and getting smarter at how to look for life. But for the moon doesn't have life.
Let's go back. Keep sending your questions in the hashtag Ask NASA. We'll board the USS Hornet on NASA Science Live. So Pierre on Twitter asks, During the Artemis program, will they bring back new lunar samples?
Oh, absolutely.
That would be yes.
Up to now, because if you think about the 6 landed missions, only at most sampled about 4% of the surface. We have not had any samples from the far side, neither from the poles, neither from the basins of these permanently shadowed craters. And I worked on a mission that crashed into one of those, and inside we found water and frozen ice, but we found hydrocarbons and argon and mercury and silver and carbon monoxide. We found a lot of things down there. So we certainly want to have samples. And if we can get some really old rocks, we can properly recalibrate our time clock that the moon still holds. And that's a...
Okay. Oh, wow. Okay.
We're looking for more rocks.
Absolutely.
Okay. Here's a question on Twitter. Hey, Dwayne on Twitter. I like the name.
All right.
Okay, watch this. What are you all's favorite planet or celestial body? Jim, you go first.
Well, I was head of planetary for about 12 years. And I would give a lot of public talks, and always when the audience questions came in, the little boys and girls would come up and ask me what my favorite planet was. And so my answer, which is still the same today, is I love all my children equally. You know? So as head of planetary, the parents got it, and I think the children were a little baffled by that answer. But every object we go to in the solar system has some element about it that's so unique, so important. It's a piece of a puzzle on how these things are put together. Terrestrial bodies and moons and icy bodies and out into the Kuiper Belt and beyond. They're just compositionally so different. It's just a really exciting time to be in planetary science.
Kimberly.
Well, how can you top that answer? When I think about how much we've learned about the solar system and will continue to learn, I think I know my favorite planet is Earth. Earth is where we are. We humans are. It is where we have the curiosity, the imagination, the know-how, the engineering to make that impossible possible. It's brought us the pictures of Pluto. It's brought us the information about the moon. It's brought us information about the sun. So I think Earth, our blue marble, our pale blue dot, that's my favorite planet because of us.
I wish you would have been my science teacher. I mean, it's just, oh, you guys are awesome. So that's going to do it for us. We are out of time. However, you keep sending in those questions on hashtag #AskNASA. We'll get to them. And this is NASA Science Live, where you can get more information and see previous shows at www.nasa.gov/NASA Science Live. And look out for the next show sometime in September, or if these incredible scientists, as they always come up with really cool science, you may have a NASA Science Live show even before that. Now, before we sign off, I have a final personal note. I've been with this great agency for nearly 40 years. I've worked on hundreds of missions spanning aeronautics, the space shuttle program, and of course science. Now I have a new mission, to travel to the planet retirement. It's been my honor, and I'm very humbled, to have worked with thousands, no, 10,000s of people all over the globe. The mentors like Jim, the colleagues like Kimberly, thank you. To all of you, thank you. This is not goodbye. This is, we will meet again. To the Apollo generation, I say happy anniversary, which I'm a part of. And to the Artemis generation, I'm going to be there with you in some shape or form because we're going. This is Dwayne Brown signing off from the USS Hornet and NASA Science Live, where science never sleeps. Thanks for joining us.